we'll do two questions on integration in this tutorial. One of them is this max x and x squared dx. Okay, this thing means that I will get whichever is the larger, x or f squared. But you see, we are integrating across this domain x equals to 0 to from x equals to 0 x equals to 2. It means if we draw the graph of both x and x squared, right? We will have the graph of y equals to x squared is this, right? With this passing nicely through the origin should be. Then after that, the y equals to x graph looks like. Maybe I'll use the other color. It just looks like this, right? That's the y equals to x graph. And then you see that let's say from this should be 1, because at 1 both x squared and x will be 1. But then later on, let's say at 2 this would be, at 2 I think this would be 4, right? Yeah, x squared would be at 4, but x would be at just 2. Okay, and we just to connect. So let's say max x squared equals to, from between, when x is between 0 to 1. Okay, I'm only interested is anything from 0 to 2, because I'm integrating between 0 and 2 only. Then from 0 to 1, I know that, okay, when x is from between 0 and 1, the y equals to x is larger, is a higher value. So this function would be just x. But when x is greater or equals to 1 and smaller than equals to 2, the x squared is the larger value. Okay, from 1 to 2, x squared is larger than x. Okay, and so we will integrate this function. Integrating this function would be the same as integrating from 0 to 1 would be x. We'll be integrating x. And when integrating 1 to 2, I will be integrating x squared. And so by rules of integration, so x squared over 2 and 1 0. Okay, raise the power of x by 1, and then these two I will just bring below. This is the formula. Okay, going by this formula, actually this also applies anywhere. So ax, where c is an arbitrary constant, but in this case we have a definite integral. That means instead of having a c here, we will substitute 1 and 0. Okay, so plus this one would have raised power by 1 and divided by 3, so to 1. So now we substitute 1, so 1 squared over 2, right, minus, this minus is by default, okay, 0 squared over 2. And then we see later we will do this, okay, again, same thing, 2, 2, 4, 4, 2, 8, 8, 3, okay, 2 cubed is just 8, right, and then minus 1/3, so minus again, because we take the top substitute and then minus the bottom substitute. Alright, so then we get this, and it's just 1 square is just 1, so half, and 0 is over 2 is 0, plus 7 over 3. That's the answer. Okay, so 3 plus if you want 3 plus 14 is 17. Alright, 3 plus 14 is 17 over 6. That's it. That's the answer. So then the other part of another question is this it is x. Give me a minute, I'm waiting for something to load. Okay, so it is this x log x square dx. and this we need to make use of integration by parts. So I would integrate x to get x squared over 2, and then I will keep log x squared. Then I will minus the integration of whatever I have integrated. I just put inside here, and then I'll differentiate this, and when I differentiate this, is just 2 log x 1 over x by a chain rule. Okay, so then we will have x squared over 2 log x square minus x. So I'll have x over 2 2 log x dx, and cos this would be minus x would cancel away with slopes. Yeah, okay, x already cancelled off with the x here, so you have 2 and these 2 will cancel, so I will have just x log x dx. Alright, actually I can do this at this stage, so I do not have to. Okay, so here this is just x log x, and that means here I will do something else. So I would keep what should I do? Now I'll keep log x, because log x is difficult to integrate. So I will I'll integrate my x. Integrating my x give me x squared over 2, and then minus this again is the integration by parts, square over 2. When I differentiate log x, I will get 1 over x and dx. Okay, then this would be x squared over 2 log x square minus x squared over 2 log x plus integration of this half could bring out outside, and x squared divided by x is just x, so I'll have dx. Okay, and not to forget plus c, because okay, plus c. Okay, we can do c1, c2, c3, doesn't matter. All these are just constants. Then this part will just be x squared over 2 log x square minus x squared over 2 log x plus x squared over 4. Okay, because this will be x squared over 2 times half will be x squared over 4 plus c cubed. So to check whether we are right, we could do differentiation. So differentiation, if we differentiate this, it will be 0. Okay. Okay, maybe we will skip this. I think it should be correct. Okay, let's say if we differentiate this, I'll have keep x squared over 2, differentiate, I'll get 2 log x 1 over x plus keep log x squared, it's just product rule, and differentiate, I'll get x. Then I'll keep minus, I'll keep x squared over 2, differentiate log x, I'll get plus plus keep log x and differentiate x squared over 2, I'll get x plus x over 2. Okay, and when this would be 2 will cancel with 2 and x, so we have x log x plus x log x square. Then this would be minus x over 2, okay, minus x log x plus x over 2. So this would cancel with this, and this would cancel with this, giving us x log x square. So this proves that our integration is correct. So that's it for this tutorial. Okay, I think one of the few rules that I use is this. I just need to. So this means that I'll differentiate whatever is inside over whatever here, right? So this is how to differentiate a log, and yep, and integration by parts. This rule LIATE, or L means logarithm. This one is inverse trigo. A is algebra. T is trigo. And E is exponential. Alright, and it happens that it also stands for this being the most easiest to integrate, followed by the next easiest to integrate and the next easiest to integrate. So this is the hardest to integrate. So therefore when we do integration by part, we'll always keep any logarithm and different and integrate the other one first. Right. So in this case, for example, this is my logarithm, so this is hardest to integrate, so I choose to keep it first, and I integrate the other one. After I integrate the other one, I just bring inside minus. This is my default always minus, and then after that I'll bring this in, and then I'll differentiate this thing. Differentiate this thing using the chain rule. Okay, so 2 bring in front, and then this one power reduced by 1. After that I differentiate the inside, which is 1 over x. So I think that's it for this tutorial, but let me before I'm doing so let's say we integrate. Okay, this is a function of x. I call it the hx. H standing for the thing that is hard to integrate, so hx, and another component is the ex, where standing for the component that's easy to integrate. Let's say when we do integration by part, it will mean that we'll integrate the one that is easy to integrate first, keep the one that is hard to integrate, minus integrate the one that is easy to integrate, and differentiate the one that is hard to integrate, and then we will keep doing this until we arrive at something that is easy to integrate. That's the idea of integration by parts. Okay, so that's all.